Instead of using long division or synthetic division to find the remainder when a polynomial f of x is divided by a linear divisor x plus 2 here, we are going to use the remainder theorem instead. So the remainder theorem tells us that if we set our divisor x plus 2 equals to 0 and solve for x, which is negative 2, if we plug in negative 2 into our function where x is, then we're going to find the remainder. So basically, you're evaluating what f of negative 2 is. So this is 2 times x to the fourth minus 3 times x squared plus 14 times x and then plus 14. And then you're going to replace x with negative 2 and you're going to evaluate this function. So this is going to give us 2 times negative 2 to the fourth is 16 minus 3 times negative 2 squared is 4. 14 times negative 2 is negative 28 and then plus 14. And we know 2 times 16 is 32 and then minus 12 minus 28 plus 14. So we know that f of negative 2 equals to 32 minus 12 is 20, minus 28, negative 8 plus 14, so the remainder is 6. So this tells us that our remainder is 6 when the polynomial f of x is divided by x plus 2. Now, in case if you're curious why this remainder works, well, let's pretend, let's say you're dividing 17 divided by 5. We know that 5 can go into 17 3 times and with a remainder of 2. So we know it's 5 times 3 and then plus 2. That's equal to 17. So therefore, let's write our polynomial like this. So we know that x plus 2 times the quotient, which we don't need to find, plus the remainder is going to give us our function f of x, which is 2x to the fourth minus 3x squared plus 14x and then plus 14. So if we plug in our x for negative 2 like what we did earlier, so this becomes negative 2, we know that negative 2 plus 2 is going to become 0. 0 times anything is going to be 0. So this side is just the remainder and equals to, again, we said we're plugging x for negative 2. And that is exactly what we did. And this is the reason why remainder theorem works. Here is another example of how we can use the remainder theorem to find the value of k for this function when it is divided by x plus 2 and it gave us the remainder, which is 14. So the first thing we need to do is set our divisor x plus 2 equals to 0. So we know that x equals negative 2. The remainder theorem tells us that if we plug in negative 2 into our function, it's going to give us our remainder, which is 14. And now we can use this information to help us find the value of k. So I'm going to rewrite this function as 2 times x to the third minus 5 times x plus k equals 14. Well, we know that x is negative 2. And now we are going to simplify this equation to find the value of k. So we have 2 times negative 2 to the third is negative 8. Negative 5 times negative 2 is positive 10 plus k equals 14. 2 times negative 8 is negative 16 plus 10 plus k equals 14. And negative 16 plus 10 will give us negative 6 plus k equals 14. Add 6 to both sides, so therefore k is going to be 20. So now I can rewrite my function f of x equals to 2x to the third minus 5x plus 20. And when this function is divided by x plus 2, the remainder is 14. Here is a different scenario of how we can use the remainder theorem to decide if x minus 1 is a factor of this polynomial function. So in order for x minus 1 to be a factor of this function, the remainder must equal to 0. So therefore, we need to divide f of x by x minus 1 and find out what the remainder is. And again, the shortcut to find the remainder is to use the remainder theorem, where we set our divisor x minus 1 equals to 0 and solve for x, which is equal to 1. And the remainder theorem tells us that if we plug in 1 into our function, it's going to give us our remainder. So that's going to equal to 1 to the third power minus 13 times 1 squared plus 39 times 1 minus 27. So now we can simplify this. So 1 to the third is 1. 1 squared is 1 times negative 13 is still negative 13. 39 times 1 is still positive 39 minus 27. So we know that f of 1 is going to equal to 1 minus 13 is negative 12, plus 39 is 27, minus 27 is 0. So because your remainder equals to 0, then x minus 1 is a factor of our function. From our early example, we know that if x minus 1 is a factor of this function, it means that the remainder will be 0. So therefore, we can use our remainder theorem here to help us find the value of k. So the first thing I'm going to do again is to set x minus 1 equals to 0 and solve for x. So x equals to 1. And the remainder theorem tells us that if we plug into 1 into our function, it's going to give us the remainder. So since x minus 1 is a factor of this function, we know our remainder is going to be 0. And now we can use this information to help us find the value of k. So we have 3 times x to the third power, so that's 1 to the third power, plus k times x, which is 1, plus 2, and that's going to equal to 0, which is the remainder. 1 to the third power is 1 times 3 is still 3. K times 1 is just k, plus 2 equals 0, so that's 5 plus k equals 0, so therefore k equals negative 5. So now my function will become f of x equals to 3x to the third power minus 5x plus 2. So when I divide this function by x minus 1, the remainder will be 0 because x minus 1 is a factor of this function.